Hey friends, my name is C and you're watching MakesItEasy, and welcome to a new video for A-level for the medicine today. We have 2.2 for modules and argument for the questions video. And we'll get started with the first question, but before we get into it, don't forget to leave a like, subscribe, and ring the notification bell so you don't miss out on any future videos. And we'll start off with question 1, or the first question. So z equals minus 40 minus 9i. Show z on an Argand diagram. So we know that an Argand diagram looks like this, where it's basically the imaginary axis and the real axis. So this is the real axis and the imaginary axis. So now that z equals minus 40 minus I and minus 9i, that means it'll be around here, minus 40. And minus 9i should be quite shallow, around here. Sorry, this is not minus 9, it'll be around here, minus 9. Therefore, this will be z. So that's z, and that's to the origin, like so. And calculate argument of z, giving your answers in radians to 2 decimal place. So we know that z lies in the third quadrant. That means the argument must be equal to arc z equals minus brackets pi minus alpha, where this is the angle alpha, right? So therefore we can just do the calculation. Arc z equals minus pi minus arctan, or basically tan inverse. Arctan of the y value for z, or for the complex number, is 9, and over x, which is 40, and brackets. So therefore this simplifies to it'll go to 2 decimal place. So arctan or tan inverse will be tan inverse of 9 over 40. And this will get us 0.2213, and you do pi minus that number. So therefore it'll be minus, let me use new color, minus 2.92 radians, giving you answers in 2 decimal place, like so. And then we have question 4, or the second question. So z equals 3 plus 4i. Show that z squared equals minus 7 plus 24i. So it's just a matter of expanding the bracket. So for a, so z squared will be equal to 3 plus 4i times by 3 plus 4i, right? So therefore you use a FOIL method to expand brackets. So it's basically this term times this term, and then this term times this term, and just do the sum of them. So 3 times 3 is 9, and 3 times 4i is 12i. And this is another 12i, so it'll be 12i plus 12i, which is 24i. 24i, like so. And this term times this term is 4 times 4, it'll be 16. But I times I is minus 1. Therefore, it'll be minus 1 times 16, which is minus 16. And therefore, this gets us minus 7 plus 24i. And that's the answer, minus 7 plus 24i, like so. And find, by showing your working, the modulus of z squared. So we know that z squared equals, from here, minus 7 plus 24i. That means the modulus of z squared is equal to the modulus of minus 7 plus 24i. And remember that modulus is basically just the Pythagoras theorem of the number. So therefore it will be root minus 7 squared plus 24 squared. And that will get an answer. Let me just put into my calculator. 7 squared plus 24 squared, which gets us 25, because it's a Pythagorean triple. So that is the modulus of z squared. And find arc z squared, giving you answers in radians to 2 decimal place. So we know that z squared, this is the point of z squared. Let me just plot it out. So it's basically minus 7 around here, and 24, which is around here. And we can see that it's in the second quadrant. That means the argument is just pi minus alpha. So the argument for z squared equals pi minus alpha, and which is equal to pi minus tan inverse, or arctan. I'm just use them interchangeably. So the y value is 24, right? So it'd be 24 over the x value, which is 7, 24 over 7. And that will give us an answer of, let me just put in my calculator, pi minus arctan 24 over 7, which gets us 1.85 radians. So 1.85 radians, and that's the answer. And show z and z squared on an Argand diagram. So let me just plot this right here. Straight line for the imaginary axis and for the real axis. So that's imaginary axis and that's real axis. So we know that z equals 3 plus 4i. That means it'll be around 3 and 4. So that will be z. Here's 3 and here's 4. Let me use a new color, like green. So around here, that will be z. Like so. Let me just write down the imaginary axis properly. I am z right here, like here. And z squared is minus 7 plus 24i. So minus 7 will be around here, minus 7 plus 24i. Oops, I have no more space, so I should probably just I'll probably just rub this axis out and just change some things so that it fits on the whole thing. So I am z 24 and here's 4. So therefore this will be z because here's 4 and here's 24, and that means this will be z squared. And that's the answer. And lastly, here's the last question. The complex number w and z are given by w equals k plus I and z equals minus 4 plus 5ki, where k is a real constant. Given that w plus z equals 2 pi over 3, find the exact value of k. So we know that we have to find what w plus z is. So w plus z equals k plus I plus minus 4 plus 5ki minus 4 plus 5ki. Therefore this simplifies to k minus 4 plus 1 plus 5ki, because k minus 4 comes from here, k minus 4, and 1 plus 5ki is 1 plus 5k, and just factorize the I out so that it becomes 1 plus 5ki. So we know that the argument of w plus z is equal to 2 pi over 3, like so. And we know to find the argument, we have to just do the tan inverse y over x. So we know that the argument for w plus z is tan inverse. The y component is 1 plus 5k, so 1 plus 5k, over the x component, which is k minus 4. So k minus 4, 1 plus 5k, k minus 4, equals 2 pi over 3. And from here, we have to just get rid of this tan inverse, right? So what we can do is that we can just put tan on both sides. So we can just do tan of this right here and tan of this right here. Because from here, tan and tan cancel out. Therefore, it will just be 1 plus 5k over k minus 4 equals tan 2 pi over 3. And therefore, this simplifies nicely to 1 plus 5k over k minus 4 equals tan 2 pi over 3. Tan 2 pi over 3 is minus root 3. Therefore, it will be 1 plus 5k equals minus k root 3 plus 4 root 3, right? And now we can basically just bring every k value to one side. So I'm just move everything to the left hand side for the k values. So it will be 5k plus k root 3 equals 4 root 3 minus 1. Factorize the k to get k times 5 plus root 3. Root 3 equals 4 root 3 minus 1. And therefore k equals 4 root 3 minus 1 over 5 plus root 3. So now we have to rationalize the denominator, so we have to times the bottom and the top by 5 minus root 3. So 5 minus root 3, 5 minus root 3, and therefore this simplifies to, let me just put into my calculator. So like so, and the bottom is 5 plus root 3 times 5 minus root 3, and therefore this gets us a very complicated fraction of minus 17 plus 21 root 3 over 22, and that's the final answer. So. And this is for this questions video for 2.2 for modulus and argument, and I hope you'll find it useful and helpful, and if you did, please leave a like and subscribe and bring the notification button to miss out on any future videos. And if you have any comments regarding my channel on my YouTube or on my Instagram, you can leave them up down below and I'll reply to them. And check out my social media in the description, for example YouTube or LinkedIn or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or you can check it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be 2.3 for a new subtopic for Argand diagrams, which will be fun and interesting and new. But until then, stay safe and happy learning.